Okay, so here we've got two functions of x, and if we differentiate them, we differentiate this first one, 2x squared becomes 4x to the power 1, and minus 4x becomes minus 4, and 3 becomes 0. If we differentiate the second one, 2x squared becomes 4x again, minus 4x becomes minus 4, and 7 becomes 0. So actually what we've got here, we've got two different functions that both have the same derivative, the same gradient function, 4x minus 4. So say we wanted to find the equation of a curve, this function, given its gradient function. Well, we'll need to do the inverse of differentiation, which is called integration. Okay, integration, the notation we use, we say y is the integral of dy by dx with respect to x. So this notation is important. This is the integral sign. This means that we're integrating, and this tells us what we're integrating with respect to. So this is with respect to x. And when we integrate, we're going to do the opposite of what we did when we differentiated. So when we're differentiating, we're multiplying by the power, and then we're taking one off the power. So if we reverse that, let's just write that out. We multiply by the power, and then we take minus 1 off the power. So that's our process of differentiation. If we want to reverse that, then the first thing that we need to do is add 1 to the power, and the second thing we need to do is divide by the new power. So that's going to reverse what we've done with differentiation. So if we want to integrate 4x minus 4, what we're going to do is integrate that with respect to x. Don't forget your dx sign there. So what we're going to do is add 1 to the power of each term. So our first term here, 4x, is 4x to the power 1. So when we add 1 to the power, we have 4x squared, and then we need to divide by this new power, which is 2. And here the minus 4 is actually minus 4x to the power 0. So when we add 1 to the power, we're going to have minus 4x to the power 1, and we need to divide by that new power, which is 1. As we saw in the first slide though, this derivative could come from many different functions. Okay, so what we need to do is add a constant of integration. We call this C, the constant of integration, because this could be many different curves, it could be many different functions. We're not quite sure. So we've got this constant of integration, but if we were given some more information about this curve, if we were told it passes through a certain point, we could put in our y and x coordinates and find out this constant of integration.